Okay, good morning class. Yes, we can use 68613. It's 68613. We can. Is everyone is here already?
Yes.
Okay.
Wait.
Wait.
One more, not yet.
Who?
Nirupa.
Okay. Alright, still waiting for others to join.
Nirupa isn't picking up.
Okay, I will text in the parents group.
Oh, I mean like the call isn't going through like that.
Oh.
Maybe no Wi-Fi code, I'm not sure.
Oh, okay, never mind. I will ask the parents. Okay, two more. Who is it? Minus Nirupa is one more. It's Abi, right? Abi Rami. Yes. Abi, are you okay? You have any problem to join? Okay. Alright, so let's continue. Okay, our lesson today. So actually last week on Wednesday, we already learned about interference of wave, right? So I will just give a quick review, okay? So actually interference is when there are superposition, right? Superposition of two coherent wave. Alright, so example, if like there are two wave, okay, two water wave that meet each other, okay, or maybe they interfere with each other, okay, so that we call it as the interference wave. So let's see a video, okay, for the interference of water wave. Okay, so you can see there are two sources of wave, okay, that is a coherent, right, and there are two waveform here, then they overlap with each other. Okay, so they produce the interference. Okay, there are two types of interference. Okay, so this is the interference of water wave. Okay. Alright, so we already learned there are two types of interference. Okay, the first one is the constructive interference. Okay, so constructive interference, it happens when the crest meet the crest. Okay, crest meet with the crest, or throw meet with the throw. And another one is the destructive interference. Okay, destructive interference. Okay, so this one happen when the crest meet with the throat. Okay, so this one we use it as the superposition, right? The superposition principle. Okay, to know what happened with the when the crest meet the crest. So here, let's say if I have this crest is the amplitude is A, and this one is also A. Okay, so by using the principle of superposition, okay, you will get the wave that has 2A as the amplitude. Okay, so this is called as the principle of superposition. Okay, and for this one, this is a negative A. Okay, and this one is negative A. So when you sum up, okay, this one, so you will get negative 2A. Okay, so this is for constructive. And what happened if a destructive? Okay, for destructive, this one is, let's say the amplitude is a positive A, and this one is a negative A. Okay, so when you add these two, so you will get 0. Okay, so this is called as the destructive interference. Okay, so this one we already see, and this is actually, okay, the video, this one also you already see. Okay, what happened, okay, by using the slinky spring, okay, by using the slinky spring, okay, what happened during the superposition? Okay, so this is crest made with the crest. Okay, so you can see the height of the crest become double. Okay, okay, so this is called as the constructive. Okay, here is actually crest made with the throat. So let's see what happened at the middle here. Okay, so this is the destructive, okay. But the wave that originated come from the left, okay, we'll just move on to the left, okay, and the one that come to the right after the interference is we continue to move to the left, okay. So this is the interference. So we use the wave superposition, okay, to find the amplitude for the interference. Okay, so let's move on to the next one. This one also we already discussed. Okay, to pulse-mate, so there will be overlap and they produce the constructive interference. Then they will continue back to the originated direction. Okay, so the one that moves from the right, they will continue move to the right, and the one that moves to the left, the one that moves to the left, we continue to move to the left, and the one that continue to move to the right, we continue move to the right. Okay. Okay, so this one also already discussed. It's I said compare the amplitude of the wave after they met with the amplitude of the single wave before both wave pulses met. Okay, so they become twice time higher. So the equation is A plus A. Okay, this one is actually the superposition principle. Okay, so what is actually the principle of superposition? Okay, so it says here when the two waves interfered, okay, the resulting displacement, okay, at the medium of any location is the algebraic sum of the displacement of the individual wave. So just now like A plus A, it become 2A. So that is actually the principle of superposition. Okay, so this is the meaning of the principle of superposition. Okay, so A1 plus A2, it will become A3. Okay. All right. So what is actually the interference of wave? So interference is actually the superposition, okay, the superposition of two waves originating from two coherent source. So what does it mean by coherent? Coherent source, so coherent source, they must have the same wavelength, okay, same wavelength and also same frequency and also in the same phase, okay. So that is the meaning of the coherence. So just now, like you see, there are two sources that produce two waves, right? So each source must have the same wavelength, and also they must use the same frequency. So that one is the coherent source. Okay, so if you don't use the same frequency of the same wavelength, so the interference will not occur. Alright, so this one is actually the diagram, okay, to show the constructive. So this one, if the throw meet with the throw, you can see they will produce the constructive interference here. Okay, while crest meet with the crest, so you can see they produce the constructive interference here. Alright, for this one throw meet with the crest. Okay, so this one is we produce the destructive. And also for this one, crest meet the throw, you have to, they will produce the destructive interference. Okay. So this is the meaning of coherent source. Okay. So means they have the same frequency, same wavelength, and the constant phase difference. Alright, so this is for water wave. Okay, so this is for water wave, interference for water wave. Okay, and this one is for the light. Okay, they will produce the dark fringes and also the bright fringes. Okay, when they pass through the double slit. Okay, and we learn just, I think before this, we learn about the diffraction of light, right? So diffraction of light also is the light when the light comes through from the single slit. Okay, but this one for interference, okay, it pass through the double slit. Okay, so they will produce the interference of of light. Okay, and this one is for the sound. Okay, they use a two loudspeaker. So each loudspeaker will produce the sound wave. Okay, their own sound wave. So then they will overlap with each other and produce the interference of sound wave. Okay, this one also we already discussed. Okay, so let's compare between the constructive interference and destructive interference for the water wave. Okay, so let's say for the constructive interference, right, you put an object, okay, where the constructive interference occur, so you can see the object will move up and down, okay, since they produce the constructive. But let's say if you put a object, okay, at the destructive interference, so the water will be calm, right? And another one, okay, let's say for the light, okay, so for interference of light, for constructive interference of light, they will produce the bright fringes, right? They will produce the bright fringes, while the destructive of the interference, they will produce the dark fringes. Okay, that is for the interference of light. So the next one is the interference of sound. Okay, so where the constructive interference occur for the sound, okay, they will produce the loud sound, while for the destructive, they will produce the soft sound. So this is the comparison, okay, for the constructive interference and destructive interference for water, light, and also sound. So we will look each of these interference, okay, for light, water, and also sound. Okay, the next part is the antinode. So antinode is a point where constructive interference occur. Okay, while the node is the point where destructive interference occur. So sometimes they didn't mention to you that this is the constructive interference, but they said antinode. So when the question said antinode, you already know this must be the constructive interference. But let's say they use a node. Okay, so you have to know that this is a destructive interference. Okay, so what is the antinode line? Okay, so antinode line is where all the point that the constructive interference, okay, that we connected all the point for the constructive interference. So this we call it as the antinodal line. Okay, while the node line, okay, where the point which the destructive interference occur, so there we connected all the destructive interference. Okay, so then they will produce a one line, so the line we call it as the node line. So this one we see later, they have the diagram here. Okay, so this one they have to use the ripple tank. So usually for water wave, you want to see the water wave, you have to use the ripple tank. Okay, so this one have to you compare the frequency. So since it's already know, you already know for the interference of wave to occur, okay, they must have the coherent source. So means coherent must have the same frequency, same wavelength, and also the same constant phase. Alright, so this one is actually for they ask you to compare the frequency. So of course the frequency have to be same. All right, and what is the name given to the source which has the same frequency and same phase difference? So we call it as the coherent source. Okay, so you can see here they have the same frequency, same phase, right? And also same wavelength. Okay, so the next one it says here you have to observe, okay, the interference pattern of water wave, okay, through a stroboscope. So what is the function of the stroboscope here is actually to trace the wave pattern. So it's easy for you to measure the wavelength, right? So mark and label on the diagram the region. So where is the constructive interference happen? So it happened at here, okay, while the destructive happened at this part. Okay. Okay, what happens to the water at the region constructive interference? Right. So here what happened? Okay, the water will move up and down. So what happened to the water at the region of destructive interference? Okay, so the water will be calm. Okay. Okay, so just now we learned about the anti-node and also node. Okay, so let's see here for the red line. Okay, so you can see at the red line here, this is all the destructive, right? Destructive interference. Okay, because this is the crest meet with the throw here. So at the point A here, so the black one, okay, the black line is actually for the crest, and the one this one the gray line here. So the gray line is actually the throw. So here at point A, you can see the crest meet with the throw. So this one is a destructive. Okay. So this is the destructive at point A here. So at the point B also, this is also destructive. Okay. So the crest meet with the throw. So then after that, you underline these 2 points. Okay. You connected it with you connected the line. Okay, so you can see here that we form a one line here. So this one we call it as a nodal line. So since you already know node is actually for destructive, right? So when you connected all the destructive interference point here, so you will produce one line that we call it as the nodal line. Okay, and at this part, the blue line, okay, so here you can see at point this one, okay, this is crest meet with the crest. So of course this one is the constructive interference. And this one is the throw meet with the throw also is a constructive, right? And at C is the throw meet with the throw too. So this one is also constructive. Okay, and the point D is actually the crest meet with the crest. So that will produce the constructive interference. So we connected all this line, okay, then they produce the anti-nodal line. Okay, since we already know anti-node is the constructive interference, right? And if they connected with all, if you connected all the line for all the point for the constructive interference, that will produce the anti-nodal line. So that this one, the blue one is actually anti-nodal, the red one is a nodal line.
Teacher, can you explain again?
Okay. Let's see, I use another diagram. Okay. So, wait, okay. So let's say I take this point. Okay. Wait a moment. Okay. So you see this one, this line, all right? This one. Okay. Starting from here, okay, this is the constructive interference, right? Since this one is crest meet with the crest. Okay, and this one is the throw meet with the throw. So they produce the constructive too. Okay, and this one is the crest meet with the crest. So this one is constructive. Okay, and then if I connected all the 3 points here, okay, so this one they will produce the anti-node. Anti-nodal line, anti-nodal line. Okay, anti-node is actually the constructive interference. Where the point that happened, the constructive interference, we call it as the anti-node. Okay, so this one crest meet with the crest, this one throw meet with the throw, this one is crest meet with the crest. So all this is actually constructive. So when you connected all these 3 points, okay, you will produce the line we call it as the anti-nodal line. Is it clear?
Yes, sure.
Okay, so that is for the anti-nodal line. Okay, so the next one, okay, is the nodal line. Okay, for the nodal line is the destructive interference, right? So here you can see this is crest meet with the throw, and this one also they produce the destructive. Okay, and this one is crest meet with the throw, they will produce the destructive. And this one also is the destructive interference. Okay, crest meet with the throw, and this one also is the destructive interference. Okay, when the crest meet with the throw. So when I connected all these 4 points, okay, then we produce the nodal lines. Okay, means this one all the destructive interference. Okay, destructive interference. Okay, so this is where I connected all the point, okay, that actually the destructive interference happened at that point, and I connected all of it, okay, that will produce the nodal line. Okay, and the nodes is actually the point where the destructive interference occur. Okay, is it clear? Any question you want to ask?
Clear, teacher.
Okay. All right. Okay, so for this part at point A, so 2 tracks met, okay? So this one is usually in the exam they will tell you, okay, the dotted line is represent what? So let's say this one, the dotted line, okay, at point, let's say at point A, 2 crests meet. So means here crest meet means the dotted line is the crest, okay? While this line, we call it is the throw. Okay, so at point A here, crest meet with crest, they produce the constructive. Okay, whereas at B, okay, when the two throw meet, so this one also is the constructive. Okay, so this one also is a constructive, this one also will be the constructive. Okay, and for this part is the crest meet with the point C, oh sorry, point C is here, right? So crest, okay, this is the crest, and this is the throw. So when the crest meet with the throw, that will produce the destructive, right? Okay, so this is how you want to know whether it produces the constructive or destructive. You have to know which one is the crest, which one is the throw. Okay, so this one is actually the line or the anti-nodal line. Okay, so for this one, I want you to label for me, okay, what is A, what is B, what is C, and what is D. Whether it's a constructive or destructive, right? So let's answer this one. Okay, A, B, C, and D. Okay, so the dotted line is the throw, while the line here is a crest. Okay, so you can see at the screen. Okay. Okay. Teacher, can someone help me send the link? Okay. Where's the code? 68613. Yes, Avinash. Okay, Sharanya, Eugene, Janet, Saji, Avinash, Tava. Welcome. Yeah. Avinash, maybe you have to refresh your link. Okay, I give 1 more minute for you to answer. Okay, so let's check your answer. Okay, so at point A, so this one is the throw me with the throw. Of course, this one is the constructive. Okay, so here is the constructive. Okay, and this one for B is the crash me with the throw. So this one is actually the destructive. Okay, and this one is crash meet with the crash. So this one also is the constructive. And this one for crash meet with the throw is a destructive. So constructive, destructive, constructive, and destructive. Constructive, destructive, constructive, destructive. Yes, correct. B and D is a destructive, constructive. Kritika, this one you shown is a constructive and destructive.
Sorry, teacher, I forgot to complete that. I just pressed it accidentally.
Oh, okay. All right, for this one, constructive, destructive, constructive, destructive. Isha, in exam, don't do like this, huh?
Sorry, teacher.
Okay. Tava, why C? What does it mean by C? Eugene? What does it mean by C here and A here? I didn't know the question. The question asks you to find Which one is the constructive? Which one is the destructive? What happened at the point A and B, and also C and D also? Is objective? No, it's not objective. Okay, constructive. So actually, Tava and Eugene, do you know which one is the constructive and destructive? Okay. All right. So the next one is the calculation. So for the interference, there are one formula for you. Okay, there is a lambda equals to ax over d. Okay. So lambda is actually the wavelength. Okay, the wavelength. Okay, for a moment, I hide this one. Okay, so lambda is actually the wavelength of the water source. Okay, and A is actually the distance, all right? Distance between the two source. Okay, here, all right, the two water source here. So this one is the A. Okay, lambda is the wavelength, and D is the distance between the two coherent sources and where X is being measured. Okay, from the source to the where you measured the X, right? And what is the X? X is the distance between two successive antinodal line and nodal line. So here is the antinodal line. Sorry, this one is a nodal line. This one is a destructive, right? You can see here at this part is a destructive. This part is a destructive, destructive. Okay. And when you connected all the line, we call it as a nodal line. So it's between nodal line to the nodal line. So nodal line to the nodal line is actually X.
Teacher,
Okay.
teacher,
Yeah.
slow down, please.
What?
Teacher, can you be slower a bit? It's too fast.
All right. Okay.
Thank you.
Sorry. Okay. So this one this one is actually if you want to find for the lambda of this, usually they ask you to find the X here. Okay. So this is the formula we use in the interference. Okay. This called as the lambda equals to AX over D. Okay. Lambda is the wavelength. Okay. For the water source. All right. Means from the crest to crest. Okay. So this one they use from crest to crest or from the throw to throw here. Okay. So this is called as a lambda. All right. And for the X, okay, for the A is the distance between two coherent source. So for this one is S1 as S2. Okay, because you already know for the interference of water wave to occur, they need a two water wave, right, that will overlap with each other. So the distance between the two source that produce the water wave, okay, we call it as the A. Okay, so this is the A. And D. Okay, so D is a distance between two coherent source and where X is measured. So let's say you measure X here, right? Okay, so let's say you measure X here. So means the D is from the source here, okay, to where you measure your X. So from here to here. Okay, so this we call it as a D. Okay, and for X is the distance between two successive antinodal line or nodal line. Okay, so let's see for the red line here. So the red line here, you can see they produce the destructive interference, right? So here at this part is a destructive. At this part also destructive. At this part also destructive. Okay, so they connected all the line of the destructive interference. Then they produce the nodal line. Okay, so this is the blue line is the constructive interference. Okay, they connected all the point where the constructive interference occurs. Okay, then they produce the anti-nodal line. Okay, so here. Okay, this is constructive, and also constructive. So they connected all the line. Okay, so this one again nodal line. All right, so the distance between the nodal line to the nodal line, we call it as X. Okay, or from the antinodal line to antinodal line, okay, we call it also as the X. So it depends for you to take whether it's from antinodal line to the antinodal line or nodal line to nodal line, okay, and also it depends on the question, okay. So that is called it as the X, okay. So we use this formula for the interference, okay, interference, okay, whether it's light, water or sound, okay, this is the formula that we will use, okay. So are you clear about what is the lambda, A, X and D? Okay, can I move on to the next part? Is it okay, Janet?
Yes, teacher. I think if teacher show one example, then maybe we can.
Yeah. So after this, we try to answer the question. Alright. Where is the diagram? Wait for a moment. Okay. Maybe I give you another example. This one is not that clear.
Teacher, is this how the diagram is going to look like in exam?
Yes.
It's so complicated.
Oh, why? Which one? Which one is complicated? You mean this one, is it?
Yeah, it looks so messy. I'm not confused.
Yes. This is actually the, if you exam, they give you the diagram like this. Okay. All right. Let me find one example. For the calculation. Because this one is actually to the light. Let's see. Maybe we have the question here. Maybe this is for the. Okay, so let's try to find this one. Okay, this one is actually you have to answer, but never mind. Later, I will just replace with another question. Okay, so here it says the diagram 80 shows an interference pattern. Okay, so what is the wavelength of the wave? So we use lambda, okay, equals to AX over T. Okay, so they ask you to find the wavelength. So this is the wavelength, all right? And A is what? A is the distance between two source, right? So here source 1 and source 2. So the distance between these two source is 2 cm. So A is 2 cm. Let me see like my life. Okay, X is actually the distance between the antinodal line or to the another antinodal line or nodal line to the nodal line, right? And for this one, the X is here. You use this one. They already give you. Okay, so this is the X, 2.5. So this is actually, if I'm not mistaken, this is the this is a nodal line. Okay, because this one is the constructive, and constructive, right? So this is the antinodal, okay, and this one is a nodal line. Okay, so for the nodal line, this one they give you from the nodal line to the nodal line. So this will become the X. So X is 2.5. Okay, so D, so what is the D? D is the between the distance between the source, okay, between the source and also where you measured the X. So the X you measure here, right? So at this line, right? So this is you measure your X here. So means the distance between the source to where you measure the X, this is called as D. So here D is 7 cm. Okay, so can you calculate for me what is the answer for this one? 5 divided by 7, right?
Teacher B.
B. Okay. Yeah. So the answer is B. So that's how you use the formula. So this is for the water wave. Is it clear? Anything you want to ask?
Yeah, teacher.
Yeah. No. Okay. So that is for the calculation part. Okay, we move on to the next one. So this is actually to show what happened, okay, before the constructive interference and during where the constructive interference occur and after the constructive interference occur. Okay, so for this one, you can see okay, there are two waves that has a amplitude A, okay, the one come from the left and another one come from the right. So during the interference, okay, they will produce the constructive, okay, and the value is 2a. So this one we use as the superposition of the wave, right? Okay, and then after that they will move in the opposite direction. Okay, they will continue to move in the opposite direction. Okay, and this one during the interference, a plus 2a will become 3a. Okay, and the one that will move to the left will continue move to the left, and the one when continue move to the right will continue move to the right. Okay, and this one is a destructive. Okay, so here they will produce zero amplitude. Okay, the amplitude is zero. Okay, and the one that move to here to the left will continue, and the one that move to the right will continue to move. Okay, so what is the what is the factor that affecting the interference pattern? Okay, so the first one, whenever they ask you the factor that affect, okay, any physical quantity, you just refer back to your formula. Okay, so since they use lambda is equals to ax over d. Okay, so here it says the interference pattern depend on the value of x. So when the x change, okay, the interference pattern also will change. So here what you have to do, x, let's say we arrange back the formula, there will be lambda a divided by a, right? So here it depends on the wavelength of the source, okay, the distance, okay, where you measure the distance between the source and also where you measure the x, and a is actually the distance between the two source. So this is the factor that affect, okay, the interference pattern. Okay, so you just refer back to the formula. What is the formula given? Okay, what the formula that we use? Okay, then you just put the physical quantity other than this one. Okay, these three, you can choose any other from these three. Okay, to put it as the factor. Okay, so just remember if the question asks you the factor affecting the any physical quantity, you just refer back to the formula that we use. Okay, so let's say they ask you what happened to the wavelength, right? When you increase the frequency. Okay, so you know V is actually equals to F lambda. Okay, so F is equals to V lambda. Okay, so they ask you, let's say if you increase the frequency, what will happen to the wavelength? The wavelength will be decreased. Okay, so that's the important why you need to remember the formula. Okay, so for this one is actually for these questions. Okay. Where is A and B? Oh, okay. So here it says compare the distance A. So of course diagram 1.5A is more further. Okay. And distance X also for the diagram 1.58B, okay, is more further. And state the relationship between A and X. Okay, so for this one, you need to use the formula. Lambda is actually equals to AX over D. So lambda D is equals to AX, and lambda D over A is actually equals to X. So here you can see when I say if I increase the X, the A will be decreased. So this shows the relationship is the inversely proportional. Or you can say the higher the value of X, the lower the value of A. Also can. Okay, or you can just use the relationship of the graph. Okay, so here it asks you to state the two other physical quantity that needs to be fixed to ensure the top relationship is correct. So this one also you just refer to the formula. Okay, so you can use the wavelength. all right, and wavelength, and also another one is the distance between the source, okay, to the place where you measure the x. Okay, so the distance, this one we call it as the d. Okay, d and lambda. Since you already use a and x, okay, in this one, so this one you cannot use a and x anymore. So another two that you can use is the wavelength and also the distance between the source and where you measured your x. Okay, and for now for 5, okay, so it says here draw the diagram x again a. So this is actually the inversely proportional, right? So you have to draw the graph that shows the inversely proportional. So you label the axis here, right? Okay, and then another one, okay, state the relationship between lambda and f. Okay, so can you answer this one? What is the relationship between lambda and f? This one I just discussed just now. By using the formula V is equals to F lambda, what is the relationship between lambda and F? Directly proportional or inversely proportional? Anyone? What is the relationship between lambda and F? Okay, so V is equals to F lambda, right? So V over lambda is F. Okay, so what is the relationship between lambda and F? Is it directly proportional? This one is directly proportional, are you sure? So me, is it, if I increase my F, my lambda also will be increased? No, it's inversely proportional. Because V is equals to F lambda, right? So V over lambda is equals to F. Okay, so when I increase, let's say if I increase my frequency, what will happen to the lambda? The lambda will become decrease. So this is the inversely proportional. If you say it's directly proportional, it means when you increase your F, your lambda also will be increased. But no, right? This one is when you increase the frequency, the lambda will be decreased. So this one is actually inversely proportional. Okay, inversely proportional. Okay, the next one, you have to state the relationship between lambda and x. Okay, so lambda and x. So you refer back to the formula, lambda is equal ax over d. Okay, so what is the relationship between lambda and x? Yes, directly, right? Because when you increase the lambda, okay, the wavelength, the x also will be increased. Yeah. Okay, so you just remember, let's say the value is 1 at the below part and 1 is the upper part, so that one is the inversely proportional. If they have the same part, let's say this one is at the upper part, this one upper part, this one is directly proportional. Okay, so as state two other physical quantity that needs to be fixed. So this one they already give you, they use the lambda and also x, right? So you need to give another two other physical quantity, okay, except for the lambda and x, okay, that need to be fixed. So what is the other two quantities? Okay, we already use lambda and x, yeah, A and D. Okay, the distance between two source and also the distance where you measured the x. Okay, sorry, the distance between the source and where you measured the x. Okay, it's mean like from here to here. Okay, so this is the D. Okay, and the next part you have to draw graph x again lambda. Okay, x against lambda. So how is the graph for x against lambda? Is it directly proportional, inversely proportional? X against lambda. So what type of the graph should I draw? Yes, directly proportional. So it should be like this. Because lambda is equal ax over d. So lambda increase, x also increase. So this one is directly proportional. Alright. Alright, so the next part, it says distance between two sources to the point of measurement of x and d. So ask you to find the relationship between d and x. So what is the relationship between d and x? Directly proportional. Yes. Okay. So this one, when d increase, x also increase. Okay. So this one is a directly proportional. So state two other physical quantity that needs to be fixed to ensure the top relationship is correct. So this one, they already give you d and x. So you cannot use that one. So you have to give another one. So what is it? Lambda and a. Yes, lambda and a. Okay. And you have to draw the graph, okay, from d and x. So this one you already answered directly proportional, right? So x against d. Remember, x against d, x is in y axis, d is at x axis. Okay? So x against y and y against x, so mean x at axis y, and this one should be d. Okay, and it's a directly proportional. So it pass through the origin. Okay. Alright, so the next part, this is the last one before I stop. So the interference pattern depend on distance x. Okay, so if the x is smaller, the pattern is closer. But if x is bigger, the pattern is less. Okay, distance longer. Okay, and the relationship here, okay, we already discussed this now. If lambda is directly proportional to x, okay, so the fixed variable should be d and a. While if d is directly proportional to x, okay, the fixed variable should be a and lambda. And if the a is inversely proportional to x, okay, so the fixed variable should be d and lambda. Okay, so I think I will stop until now first. So we continue tomorrow, okay, for the interference of light. Okay, so I see you tomorrow. Okay, so take care, everyone. Okay, bye.
Thank you,
Thank you,
teacher.
teacher.
Okay,
Teacher.
welcome.
Teacher, bye.
Bye.